If you are new to the channel, then subscribe the channel and press the bell icon for further notification. Okay student, welcome you all to this new lecture in machine series. So today again we will be solving 5 questions starting from question number 96 to question number 100. Okay, then let's try to solve these 5 questions. Okay, if you come to question number 91, the figure shows an ideal 3-winding transformer with the ratio 4:2:1. The resistor of 10 ohm is here and the reactance of 2.5 is there. The supply is of 400 volt. Okay, the voltage supply phasor 400 angle 0, the supply current phasor I1. So you shift this resistance, you refer this resistance to primary, you refer this reactance to primary. See what the impedance it is coming here, and what will be this one. Whatever resistance it is coming here, the reactance will be parallel to this one. Why? Because this I1 is the summation of this current and this current. Whatever current it takes, it will take from this. Whatever current it will take from this. You can check this one also. Here the current direction is not given, but it is generally always taken this winding in such a way. So this flux generated by this should oppose by this, so that this minus this always remains constant. So any increase in this will try to reduce this one, but it will not allow this reduction because this E and B. So because if it get reduced, then U1 will reduce, then more current flow. So that current will again increase that U1, so that U1 E2 remains same. So that is the idea. So ultimately they will oppose each other, and any increase in this current will be always supplied by this, because if it starts increasing, then phi will decrease, due to which E1 will decrease, then more current will be pumped, so it will again increase that E1. So E1 and E2 will never get decreased. So this I1, any increase in this one will be supplied by this one. So if you increase this one, it will be supplied this one. If you increase this one, it will be supplied. So this I1 will be summation of this I2 dash and this I3 dash plus this magnetization component. So ultimately this and this, when it reflected to primary, they will be just parallel to each other, because your I1 is simply summation of I2 dash plus I3 dash. If I am taking IM as a 0 plus IM, this is one you can take negligible. So that means this and this resistance are connected in parallel if you are referring that side, R dash and XC dash. So what will be R dash? Your R dash will be equal to, if you refer this one 10 into, it is always K square. You always think whether you are going to higher side or lower side. If you are going to higher side, then it should increase. It is lower because it is 4, it is 2. So it is going higher side, so it should increase. So it is 2 times 4:2, so it will increase, that is 2 square. I always remember this one, otherwise you will get confused. 2 divided by 2 square or into by 2 square, whatever. So you always think if you are going to higher side, it should increase. So if your ratio is 2, 4:2, either 2 or half, so whatever you do, it should increase. From 10 it should increase, so you multiply by 2 square, so it is 40. Similarly your X dash will be also equal to minus J 2.5, because it is reactance, capacitance. So and the ratio is 4 now, so it should also increase because it is going higher side. So 4 square is 16, so it is minus 40. So what will be total impedance that is reflected to primary? 40 is in parallel with minus J40. If you do this parallel combination, 40 into minus J40 divided by 40 minus J40, it will be 28.28 at an angle of minus 45. So what will be your I1? That supply voltage be 400 at an angle of 0 divided by this Z. If you do this one, it will be 10 plus 10J, that is your option C. Now if you come to 92, a 500 kVA 3-phase transformer has an iron loss this and full load copper loss this. The percentage load at which that is at maximum efficiency. So you know maximum efficiency, constant loss and copper loss are equal. So your iron loss should be equal to K square into that copper loss. So if you solve this one, K is equal to 70.7%. So at this much percentage of loading, both these losses will be equal. They will have maximum efficiency, that is option B. So if you come to 93, this auto transformer we have already seen, they have connected in this way. 3300 and 23 volt single phase transformer is connected as an auto transformer, the nominal rating of the auto transformer. Okay, so this is 3300, so obviously 230 will be this one. So what is the maximum current you can, so what is the total V out is equal to here? You can do it either from this side or this side. This side it is easy because this current will be I2. So if you know this current, this terminal voltage and terminal current you know, so you can V into I, this will be your output. So if your V out is equal to 3300 plus 230, that is 3530. And what is the maximum current that it can allow? This one, 230 volt. So 230 volt maximum current, that is I out. So this current will, that whatever maximum current you can flow this through this winding, because this is coming from this transformer. So whatever, for what current this winding is prepared for. So let me calculate that current. This winding is prepared for maximum this much current, you can calculate from here. So that much current only you can take it out. So the maximum output current that you can take it out is 50 into 10 to the power 6 divided by 230. So therefore your kVA, maximum kVA rating, is equal to 3530 multiplied by this one, 15 to 10 to the power 3 divided by 230. If you do it well, it will be 767.4 kVA. That is your option D. Now if you come to question number 94, the resistance and reactance of this star to delta distribution transformer is this one. The phase impedance of the transformer referred to primary, if you are referring to primary, okay. Again phase impedance, that you have to be very careful. So impedance per unit phase I am writing. So all the bases should be base in per phase. So this is your per unit, that multiplied by base. What is its base? You are referring to which side? Primary. Primary is delta. So whatever phase voltage, that will be your line voltage. So it will be 11,000 V square divided by your power. So power is 100 kVA, but that is for 3 phase. So per phase it should be this one. So power is also per phase, voltage should be also per phase, because it is delta. So voltage per phase and line same. So these 3 is the factor, because it is per phase, that's why these 3 is coming. So if you solve this one, I think you will get 72.6 plus J 254.1. That is your option D. Now if you come to 95, the equivalent circuit of a transformer has a leakage reactance of X1 and X2 dash, the magnetizing reactance Xm. So magnetizing is having a very high value because it is connected in parallel. So this should having a very high value, otherwise all the currents will come here. The current is very minimum, so it should have very high value. So Xm should be very high, and this leakage reactance is very small because we don't want to get more leakage, because this is the wastage. Leakage reactance is that flux which is not passing through that intended core. Suppose this is my core, so flux is not passing, going through the flux is bypassing, flowing through this is the leakage. It is not passing through the intended path. So that should be minimum as possible, and both are equal, because whatever leakage is there because of same core, so they are almost equal. So your X1 and X2 dash, the leakage flux is equal in both sides, but that is very very small than your Xm. Xm is very very high. So that is your option D. If you like the video, then press the like button and please give your valuable comments in the comment section.